So this is the last section in chapter 4, which is applications of trigonometric functions, so you can see how useful they are. And this section is called area of a triangle. This is the last section that will be on the next exam. So your objectives here are going to be to find the area of SAS triangles. And then we're going to have a special formula for finding the area of SSS when you know all the side lengths. So it's a pretty cool little formula. I don't expect you to memorize these formulas, but you should know how to use them. So the area of a triangle, you should know this formula for the area of a triangle. It's 1/2 the base times the height. So K, we're using K because A is going to be a side length, so we don't want it to be confusing. So the area is 1/2 base times height. And this doesn't matter how the triangle is oriented. You take the highest spot on the triangle and you drop it down to whichever side you have made the horizontal side, and you drop a perpendicular down, and that is the H. And then the base is the length of the B. So it doesn't really matter how the triangle is oriented. It doesn't have to look like this. You could turn the triangle any direction, and the base will be the length of the side you've picked as the horizontal side, and the height will be the highest point of the triangle, drop perpendicular down to the horizontal that the base is sitting on, and that height will be H, and that line's called an altitude. So we're first going to find the area of SAS triangle. So if we know two sides and the angle between them, which recall that this is the setup for the law of cosines if we're asked to solve the triangle. But here we're looking for area. So we can use this formula if we know B and H, but that might not be what you have. So if instead you know a side length A and a side length B, and the angle C that's in between them, we can find this area using trigonometry. So notice that the sine of angle C is the opposite side length H over the hypotenuse A of this smaller right triangle that's inside the bigger triangle. So the sine of angle C is length H divided by length A. So that means if you solve for H, you get H equals A sine of capital C. So you can substitute that in the formula on the previous screen for the H. So instead of H, you put A sine C. So now you get a new formula that says, oh, okay, the area of a triangle, if I know two sides and the angle in between them, it's going to be 1/2 side length, times the sine of the angle in between them. So this is going to work for any two known side lengths. So if the two side lengths here are whatever letters they are, and then the third letter is the angle, then this formula is going to work. So if you know side length B and side length C and angle A, you could also find the area. So you see how it really doesn't matter what you call the names of the sides and angles. It's, do you know this angle and this side length and this side length that make up the angle? That's the relationship that you're after to be able to use this formula to find the area of the triangle. So this triangle, we can see that we know this side length and this side length and the angle between them. So if you think about that, this is H. You can see that the sine of 20 degrees is going to be H over 2, looking at the smaller inside triangle. So H equals 2 times the sine of 20 degrees. So that says if the area is 1/2 B times H, then it's 1/2 the base, which is 5, times H, which is 2, times the sine of 20 degrees. So you're going to multiply those all together and make sure you're in degrees. And I'm getting about 1.71. And this is going to be in square units. So I'm just saying this to remind you that area is in square units. And then notice you don't have to have a triangle drawn to be able to solve this. If we notice we have side length A and side length C, and B is the angle in between them, we can just use the formula. Let's say K is then going to be 1/2 side length A times side length B times the sine of the 10 degrees. So we're going to get about 0.17 square units. That's a very small triangle. Okay, so the second objective is find the area of SSS triangles. And Heron has come up with this amazing formula that says if you know the three side lengths, A, B, and C, then first you calculate this number S. And you're going to want to store this in your calculator somewhere, because then you're going to do S minus A, S minus B, S minus C, multiply those together, and then multiply again by the S, and then find the square root of that. And that is going to give you the area of this triangle. So let's first calculate the S for this example. I have 1/2 A plus B plus C. So S is 13/2. So then I know that the area is going to equal the square root of 13/2 times 13/2 minus 4 times 13/2 minus 3 times 13/2 minus 6, all under this square root. So I'm going to have 13/2, 5/2, 7/2, and 1/2. Square root of that. And now I'm going to get an approximate because I'm going to do this on my calculator. And I'm getting about 5.33 square units. So this is going to be a pretty easy homework assignment. And that's all there is to this section.